let's continue with the application of blueprint reading in this real project. And in this part, I show you how to determine the formwork for the tangles, formwork for roof. It should be the same. You can apply the same concept. And then water stop, rebar for the tank bottom slab. So let's work on here. You see drawings and continue with the spreadsheet that we had. We went over the volume of concrete, and then now let's do the for the formwork and for the go and pilaster. So again, we have east and west go. How can I determine the formwork for that? So you see the go in plan view. So you have that one. So basically, to set up the go for the concrete, we need to have the formwork for this side, right? Of course, the other side as well, so that it can be a concrete can point in there. So it determines the square foot contact areas. To determine square foot contact areas, one side and then to time 2. So you see the one side in here, and the side, the other side, the height of the goal. The side of the goal, the height of the goal, you need to see the cross section of that. So that here go down to this SM3 and the height of the goal in there. So you know this and the height. It's not about the thickness. Okay, so that the same process we will apply for other goals. Now let's talk about the east and the west goal, and that what we have in here. You see that east and west 55. So it here it means that for this side I have 55, and you can utilize the number we have in there for the goal for the concrete, right? It's the same dimension, and then the height we already have it in there, so it's also the same. So that's why I put equal to there, that, and then you have both sides. To put the concrete, I have both sides formwork, so that now time 2. So you have for one side, two sides, and it's square foot contact areas. The same for south goal. I don't need to repeat. So you have to go yes, and then the south goal, the dimension we already do it in the concrete. We can apply that the same. North goal, middle goal, and pilaster. Just get extra on this side and this side. For the formwork, we can get that, but it's very small compared to other square foot contact areas. You see, I just go to the detail, but in the real life, you'll be able to just account some percentage for the formwork for pilaster. Then it can be okay. That you can see here, the total there for the goal is 13,000 square foot contact areas. For the pilaster, it's only 438. So it means only a few percent. So we just add some percentage instead of going to detail. That in real life we should do the estimate. So that is the formwork. Talk about the formwork for the roof. So for the roof, it's a little bit different. Not for the roof, we have the roof cross section of the roof. So you have the formwork is basically to put the roof on here. I need the formwork underneath, so I need the width and the length. It's different from the column. So the width and the length of the roof, we can see the roof plan times is 55, about 55 times 113. We can get the formwork for the roof. So that's why we have, see that 113, 56.2. You get the formwork for the roof. And of course, we can put some extra for the slab, and that you can see in there that I show you for that. And you can track that where that number come from. It also have a beam somewhere in here. So utilize the dimension we determine in concrete and can apply that for the formwork. That is the bottom line there. So that formwork, water stop, what is that about? And where it show it in the location, and that is the most confusion or we have there. So you see water stop between you do the old concrete and new concrete. You cannot pour the place the concrete for the whole tank, maybe the bottom slab, and then go. Then we need to have the water stop. Otherwise here the wastewater, it can leak to the environment, so they need to show the water stop. So where it show, if I cut down here for one cross section, and you see the section there, the O and the new concrete, this bottom slab and here, and they have something there that info what's the top. It's small here. So they say construction joint with 6 inches water stop, and see this detail. See this detail. Where that detail come from? We can go down to the drawing further. Go down. So you see the different detail that we have for the old and new concrete. Okay, so that is go base slab construction joint, and that is what they refer to. You see the base and the go, and you see the water stop, and that water stop that they specify is 6 inches, as you can see, and that what we have water stop. So WS is mean water stop, to block the water leak out to environment, etc. If you want to see, you can Google water stop, what it look like. So that is the typical water stop. It can go with different color, blue, gray, yellow. So how it's set up, for example, here is drawing that way they set up water top between the bottom slab and the wall, so that it can be eliminate the leaking between the old and new concrete. Or here with the yellow, they can do that. So basically measure by linear feet, because that when they say 6 inches, so that it will be the width, and we just measure how many linear feet of the water stop. So if it the base and the goal, so the perimeter of the goal at that construction joint, it determines how many linear feet I need. So that go to here to just go for this drawing. So it goes surrounding, it go in the intersection between the bottom slab and the goal. It goes surrounding this tank, or surrounding that tank, and with that we can have the number there for water stop in bottom slab. Okay, so that one side, this one, and then you have a bottom slab. For the slab first, it's for the slab, then it will be here. Just show you the construction joint. This is construction joint there. So if they also need water stop, and it's something like this. It's something like we have it in that one. So the bottom slab, if you have to slab, you cannot place concrete for the whole big slab, because that will have thermal expansion. It will crack in the concrete, and that will be leaking. So they have to make the expansion joint, and that the water stop need to be go through to connect between the old and new concrete. For this one, because that tank, the length is 116 feet, it's too long, so they break down the expansion joint here. Similarly, they also have expansion joint this way. So go one side from here to here about 55, and then from here to there about 116, and that way we have that number about 55 to be exact. To read the number 57, 116 feet, that is the bottom slab. And then roof slab, it do the same. The roof slab, they also have the construction joint, as you can see here, and then the expansion joint they have here go through. So that is the item we have for the water stop there. And for the wall, do the same. Expansion joint, the same for each item, so you can be able to find out the water stop for that need to be located in the wall between the slab, the bottom slab, and the wall. For the rebar of the bottom slab, and where that number come from, and I think I also went that briefly in the previous video. So you can see that from cross section here, you see bottom and section B in drawing 78 SM3. So you have here number 6 inches on center each way, top and bottom. So apply the concept we did in problem 3 in unit cost estimating lesson. You can be able to find out how many number by determining the length of it. So for example, this item, it will be go through the length of the tank, and then this item, the width of the tank. Okay, so that both sides. So with that, we apply the equation, and when we can be able to find out. So let here, how can I find out? So 56, which is about to lay out the other the width, times 12 unit conversion. 1/4 is 6 inches. That on center 6 inches, and you can see there plus 1 because that is explained to problem 3 of unit cost estimating lesson, and time 2 because top and bottom, so that you have that there, so that you have here, so that is the number, and the length, it should be the other length. If it laid out on the width, then the length, it will be the length of the tank, which is 1/16. Similarly, if the length is to the width 57.5, then the number you lay out, it will be through the length 1/16, but subtract the protection, etc. So 1/13. Same equation we apply in the problem 3 of unit cost estimating, and then we can find out how many numbers of the rebar and what is the length of each of them. And this one, we for number 6, is in number 6, the unit weight is 1.502 pound per linear foot. Then we can be able to find out the weight divided by 2000 to get the ton, right? Pound to ton. And then it how many of them? 2 to 6. So here we can get for the rebar total is about 40 ton. A lot. The last item is dowel. Dowel is basically here you see the dowel, and that connect between the bottom slab and to the wall, and that is dowel. And similar here, dowel, you have that one. And also they show you the length of the dowel from here, connect 6 feet, right? 6 feet. And then go to see that detail 5, ASM 11, so you can see the dowel. That's the detail 5, and that is the dowel, and it's the connection from here to there have to be 6 feet. 6 feet as it's shown in that, and then you add that the thickness of the bottom, it's, if you recall, 1 foot and 6 inches, and the extra length in here. So that determine the dowel is about 8.5, 8.5 feet, and that also number 6 on center. How many number I can find out? So the way dowel located, it's cross whenever have intersection between the wall and the slab. So if you have here, it have to go through, yes, go through all the side, and of course in the middle they have a wall in the middle. Walls also have that, so you have one side, 4 sides, and the middle one have another wall as they show in the drawings. So you have to find out the total length and divide by the 6 on center, so you can be able to get. So it show it in the drawing here. It be go down to the whole side. That is the dowel should go, and both sides, and you can see the cut. Each time have 2, 1, 2, 1, 2. So that's why we need to figure it out what is the total length. You see that here, the length and unit conversion, 6 inches on center plus 1, and 2 sides, and then we have east, north and south, so you have time 2 again. Similarly, we have 56 for the width, then 2 each side. We have 2 dowel for each cross section, as you can see here, and 3 why 3 not 2, because for the go in south, in the east west, we have 1 go, 2 go, and 3 go, so that's why we have the dowel. And of course, it's also number 6. So the if you go to the exam 1 reference, that is the number 6, the unit weight is 1.502, and then you can determine the ton. Divide by 2000, you can find out the ton. So that walk through, and hopefully you can be able to practice and with yourself to do extra work in here, to do the rebar for the tangles and pilaster, tank roof slab, etc. If you master with that and the drawing with you, and then you can be able to do project, and hopefully you can be able to read the drawings for any actual drawing that you have.